can't expect your team to manage one with this.
Hello everyone and welcome to COMP1511. Woohoo! I hope that some of you are on campus or got to be on campus this week. It's been really exciting seeing the campus come alive again. Lots of people today. It was very nice to see, and people enjoying themselves, even more nice to see, and hopefully enjoying the lectures, which is even nicer to see, maybe, although the lectures are online for the most part. But welcome. I'm your lecturer for COMP1511. So my name is Sasha, and I will be looking after you in this term and all of your lovely tutors, which we will all talk about in a second. So today's lecture, probably not the most exciting lecture that you will have all term, but it's going to give you a lot of the background and a lot of our course outline, a lot of how the course is run as well. So hopefully we'll give you a bit of an indication of what's happening this term and prepare you for it all. In the chat with me, I have the lovely Shrey, who is also the admin for the course. I have the lovely Tammy, who is one of our tutors and has been around for a while. I also have with me in the studio another of the lovely tutors, Tom, and I saw Tom number 2 in the chat as well. So it's all happening. I think I even saw Ben in the chat, who's one of the other admins. So they will be answering all of your questions, and I will as well, but sometimes there's too many questions, so they will make sure that we're answering everyone's questions. If we don't catch a question that you have asked in the chat, please ask it again, as sometimes it scrolls up, and we miss a question or two. All right, let's get started. Yeah, so we've got, as Shrey said, it's very confusing because they're both Tom K, so I call them Tom number 1 and Tom number 2. But to make it even more confusing, I swap around which one is 1, which one is 2, depending who's standing closest to me. Okay, here we go. Time to get started. I shouldn't do that, boys. I regret it now. All right, today we are going to talk about our welcome and introductions to everyone here. We're also going to talk about the course administration, how COMP1511 works. We're going to talk about how to get help and the best ways to approach learning programming. What is programming? What is Linux? Working in Linux, and a first look at C. I know that some of you had the wonderful adventure of having your tutorial before your first lecture today, and you were in the very capable hands of our amazing tutors who hopefully helped you along. And if you didn't understand everything from that tutorial, don't worry, more things will be cleared up in the lecture, so we will be able to talk about everything, so don't worry, but they would have helped you along. This is only an issue for this first week, okay? So from this week onwards, it will line up better and you won't have this issue where you're coming into your tute without ever having known the lecture content. All right, so who am I? My name is Sasha and I really love dogs. Before we were allowed to come on campus, I was sitting in a room with my dogs. So I still think of them as teaching assistants. I did pose quite a challenge to my team, to my admins, if they can figure out a way to sneak 2 large dogs into the studio where I'm recording this lecture from. That's a lot of brownie points, but no one has yet figured it out, so we'll see what happens. So I come from a background of education, but I also have I obviously did computer engineering and more computer and more computing. And then I decided I'm going to go and learn how to educate people because I want to see how people learn best. So I have a really big focus on how to solve problems and how to, teach those introductory subjects, it's really important to kind of cater to a whole range of audiences there. So hopefully we're going to have a really good time. I love to have a good yarn as well. If you catch me, please say hello around the uni. And if you also in the chat, I love to have a yarn as well. So probably not in the first few weeks because there is a lot happening. We want to get through a lot. But in later weeks, suddenly I start chatting in the chat a lot as well. So yeah, so you might see my dogs if I get COVID and have to isolate. Other than that, unless my team realizes how to sneak them in, you probably will not see them behind me. which is a shame because they also bark usually at pretty good moments. Oh, I didn't mean to go backwards. Let's go forwards. We move forwards. Okay. I also have 3 lovely admins on our team who help with the administration of the course because it's a large course. So we've got Tom, who has done it for many, many terms. And he writes a lot of scripts, doesn't really sleep much, from what I understand, and has 2 beautiful cats. Then we've got Shrey, who will be your main point of contact, and Shrey also seems to not to sleep. I don't think anyone at CSC really sleeps, is the feeling that I get all the time. And Shrey is going to be your main admin for this term, and he's going to be your main point of contact if you have administrative issues. So you come to me or you come to Shrey. And then we have the lovely Ben, who you will see a lot of on the forums. He is going to be looking after our forums and answering all of your questions. He is very, very good at answering your questions on the forums, very, very good at explaining things. Some of you even today had him as your tutor, which is also exciting. So we also have just a lovely, lovely team of tutors that kind of come together to help you and support your learning. Shrey was kind enough to create this beautiful collage for me in a heart, because I feel like this is the feels of this team. So I hope that you guys feel that as well, that we can support you in your learning and that we can help you, and that you also feel very comfortable asking us questions, because we are here to help you learn. And we're here to help you get through this course, and not just get through this course, but also learn a lot in this course as well. So everyone here is really passionate about teaching. Everyone here is really passionate about helping. And no question is ever a stupid question. We love questions, okay? Very important. And no question is too small, because usually it's the small things that stop you from, from kind of going forward. So please, if you have any questions, ask away in the chat, ask away on the forums, and so on and so forth. Okay. All course information is found on our website, not on Moodle. If any of you had gone to the website 2 days ago, you might have noticed that it's changed a little bit, because this is something that we also like to do. Experiment with things, try and make things a little bit better all the time. So we're just trialing a new web page, some ideas that we might be changing as well. But so everything that you need is on our website. And maybe can I please get someone to post the link in the chat to the website? And on the website, you will find all the links to the lectures. You will find all the links to everything that you need. Oh, thank you, Shrey. So far ahead of the game. Not even funny. Yep, so our webpage. Okay, communication, admin related. If you have any admin related issues, please contact us by using the course email. So cs1511@csc.unisw.edu.au. Okay, this is quite important. Just hold on a second. My pen is it working? It is not working. Oh well, too bad, so sad. My pen is not working. I was hoping it would work. It was working like 5 minutes ago. Okay, so email us at the course email. Any enrollment issues, you have to contact the Nucleus, okay? The Nucleus Student Hub. Unfortunately, we cannot help you with enrollment, only they can. So you have to contact them if you have any enrollment issues. If you have an ELP plan, so if you have an ELS plan from the Equitable Learning Services, please email me directly. And there's my email directly over here, a.vassar@unisw.edu.au. Please email that to me directly, and we will put all the provisions in place. Okay, the forum is a fantastic place to ask questions if you have about the course. We basically have a, you can ask anything. There's lots and lots of categories. Oh, look at this. It cuts me off. Okay. We have lots of different categories, and someone is always monitoring the forum. So you are really likely to get an answer quite fast on the forum, a lot faster than when we are somewhere else. Ask questions in your tutes and labs. They're also your class time is a great place to ask questions. We're so excited to be back in person, face to face. It really makes such a difference to be able to see you all, chat to you all, walk around and actually, engage you and see where you're at and help you out as well. So ask questions in those tutorials and the lab sessions. And also we run help sessions. So we will announce a schedule to our help sessions very shortly. We'll probably start them at around week 3. Now this time around, we've got a Hail FastPass system, which we will show you before we, ask you to use it. We'll provide it to you shortly. Tom is just finishing writing it because that's how we write software to help us with this term. And it is a great place to get help outside of normal lab or tutorial times. Now, help sessions get very busy around assignment due times, so please make sure to start assignments early. We'll talk about that in a second. And get help as well as you need it, as opposed to leaving everything to last minute. I feel like everyone is always saying that, don't leave things to last minute. So here you go, I've said it again as well. Okay, what is COMP1511? It is your introduction to programming, and this is where, I hate to use the word journey, but this is where your journey starts. So now I feel like we're running some sort of reality TV series here where everyone goes on a journey and you learn so many wonderful things. So this is super exciting. So let's sort of get this introduction to programming. I hope that you guys fall in love with programming and with coding and with computers, and that you want to continue kind of doing computing. It's okay to, find this course really, really hard. I have to say, when I first did this course many moons ago, it was a different course. It wasn't really this course. Let's just say when I did my introduction to computing, I found it to be a very difficult course. It was very different to anything that I've ever done before. I didn't have a lot of coding experience, so it was quite confronting when I first came in. We try and go slow in this course, but sometimes we do speed up, so be wary of that. Make sure that you ask us questions if there's something that you don't understand, and we can help you, we can catch you up, and we can do a lot of things. So please, it can be hard to pick up these concepts because they are probably some very novel things that you're hearing for the first time as we go on with this course. So you might find something hard. Please don't get discouraged if you do find something hard. It's really, it's all about practice, and it's all about solving lots of different types of problems. And it's all about asking for help as well. So it's really, please, lots of questions and lots of engagement and interaction as well. Computers can really only follow instructions that we give them to solve problems. So computers are not really actually that smart. We are the smarter species. For how long? Who knows? But so we are the ones that give them those instructions. And when we write our code, when we write our programs, that's when we provide the computer with a set of instructions. So when you think about it, when you're writing your code, you have to be very, very specific about what you want the computer to do, and you have to be descriptive in every step, because you have to remember a computer is not actually that smart. It really only follows what you're telling them to do. So all the brain power is really coming from the human who's telling the computer what to do. Of course, there's a lot more calculating power that a computer has, but we're the ones that are still in control, maybe for a short time. So problem solving is a very important skill in computing and in introductory computing, and it can only be built up with practice. So you have to be able to see lots of different problems. You have to be able to solve different problems, and we hope to give you that during our labs with problem sets as well. So we really want to be able, for you to be able to get a lot of practice, and also there's going to be different types of questions that allow you to be challenged as well if you so wish to be challenged. So we assume no prior knowledge, okay, and 0 previous programming experience. So we teach you the fundamentals of programming. We teach you how to approach the problem solving. We teach you how to talk to computers in a common language. Well, we're going to teach you how to talk to computers in C. But we really assume 0 knowledge. So for those that have programmed before, and I did go on the forums to check out the poll, which was a bit exciting. I saw that some of you had programmed before. Not many were advanced programmers. Mostly people have never programmed before, so it's nice that everyone's kind of on the same level there. So that's the level that we're starting at. We assume no prior knowledge, so we explain everything from scratch. Okay, lectures, 2-hour sessions twice a week. They are streamed online via YouTube Live on Tuesday, 4 till 6, and the glorious time of Friday afternoon, 3 to 5. I hope that you can all join me, because there is no better thing to be doing on a Friday afternoon and evening than to be in an introduction to computing lecture. Week 6 is flex week, so there are no formal lectures, so you don't have to go to the lectures. There are no classes. We don't teach you any new material that will be examined, but we have organized a very exciting series of lectures on ethics in computing that are optional for you to attend, but quite interesting. I would strongly recommend, if you have the time or the inclination, to log in, and I'll provide more details on this as the term goes on. If you have a question, again, please feel free to ask it in the live chat. We've got lots of people going in the chat. The only thing that I ask you is that you have to please be respectful of others at all times. Everyone is here to learn. We want to create a supportive environment where people feel comfortable asking questions. And if you know the answer, please feel free to pitch in, but always be respectful of others. So no rudeness will be tolerated. We will kick you out of the live chat, really. So please be nice to each other. Okay, what are we going to talk about in the lectures? As I said, this lecture here, right here, this first lecture will definitely be the most boring lecture that you will go to in this subject, okay? I'm sorry about this, but when you have to share course information, there is really no other way to do it. So we are going to, normally in the lectures, we're going to talk about the theory. So what are we trying to understand? We're going to have a lot of demos. I like to code, and I love for you to code along with me. So I'm going to be sharing the code that I'm writing in the lectures, so you will always be able to access it. As soon as I press save, you'll be able to see what I've written. So you can code along as well and not get lost, hopefully. So we're going to do some problem solving. We're going to talk through every single problem that we're solving, how to solve it. We're going to talk about some other stuff. Sometimes I like to go on a tangent and talk a little bit about some trivia or some fun facts. You might get that. Sometimes I'll mention things that are not examinable in this course, but I feel are important to build your understanding of what's happening. So any lecture slides are available from the course website. And lecture recordings will be in the YouTube playlist. They're linked via the course website. They're also available as Echo 360 on the Moodle page as well. So we're going to have, there's a lot of ways that you can get the lectures as well. They are recorded. They are made available to you. We want you to be able to watch them and re-watch them. Speed me up, slow me down, whatever you need to for your own learning. Okay, so tutorials, 1 hour classroom environment. They go further in depth into the topics that we're teaching. They also will help you to cover off the concepts that we did in the lectures, and a tutor will also explain them again, so it gives you that extra practice that you might not have had in the lecture time. And we aim to learn how to solve the problems before we write any code, so we aim to do that in our tutorials. And tutorial questions will be available in advance of the tutorials on the course website yet again. So everything is on the course website. Everything is on the course website. Okay, good place for interactive learning. You have time to discuss and work through problems there. What we try and do is we try and make them as interactive as possible. And we will also be, this term, getting your feedback after every tutorial, because we want to know what was done well and what we can do to improve. So online and face-to-face, please check your timetable to see if you are online or face-to-face. For online classes, we use Blackboard Collaborate. If you are in an online class, please try and turn your camera on if you can. You don't have to, but if you can, turn your camera on. And we do love seeing pets. I have loved seeing the forums, just like cuteness overload. Some of your pets are just so cute. I have seen so many just cute dogs, cute puppies, cute bunnies. It's just too much. I haven't been able to focus. There's been too much cute. And we do release the sample answers as well after the last tutorial of the week, so that you can see what on earth is going on. Okay, labs are 2-hour sessions and they come straight after the tutorial. Oh, I'm standing right in front of the, I didn't even see that. Let me move myself. There you go. I've moved myself so you can see the lecture slides. No one even commented that they can't see. Anyway, okay, so practical coding in labs includes working in small groups. So sometimes we might do pair programming. We're really excited to be face-to-face again because we can do a lot more of that pair programming, and we'll talk more about what pair programming is. But it's basically increasing your brain power to solve problems as you code with someone else, which is really, really exciting and a really fun thing to do as well. So the lab time is a really great time to check in with your tutor and your AT, your assistant tutor, because you can ask them questions about if something is not working, if you don't understand something in the code that you've written. So you will be able to, ask questions in that time. Problem sets that you will complete in the labs will be marked automatically. They'll count towards your final mark. So it's 15% off the total over the term. This week's lab problem sets do not count towards your final mark. It's just a lab where we hope to introduce ourselves to you, get to know you, set you up so that you're ready to go for the next week onwards. Okay, so that's the problem sets. In each of the problem sets, we actually do a difficulty rating. So there's 1 dot, 2 dot, and 3 dot exercises. And we really hope that all of you can do the 1 dot exercises. If you get to a lab where you can't do anything in the 1 dots, please ask your tutor for help, okay? Because they can pull you out of the lab. I was going to say into a breakout room because I'm so used to being online, but they can sit down with you and they can help you get started. They can see where perhaps you don't understand something. So it's really important. If you can't do any of the 1 dot, you need to let us know so we can help you and so that we can, make sure that the gaps are filled. So 2 dot exercises, we would like for everyone to attempt them at least. 3 dots if you want to extend yourself, they still count for marks. And then we also have some challenge exercises. So they're not really necessarily, they kind of give you bonus marks, which means that you can get extra marks that contribute towards your lab only. So nothing else. Sometimes though, those challenge exercises take so much time that perhaps it's not worth the extra few marks. But for those of you that want to challenge yourselves, and for those of you that want to have some, sort of, anger at the computer when something doesn't work, I strongly recommend the challenge exercises. They can be lots of fun. But of course, once you're working it out and when you're in the throes of working it out, it can be very frustrating when things don't go your way. And there's no tutorials and labs in week 6. It's your time to relax. Okay, assignments. Here we go. Assignments. You're going to have 3 assignments this time in this course. Please, if you take anything away from this lecture, it's that I would love for you to start the assignments early. Okay? They are not the kinds of things that you can do last minute. I do not advise you to try and do it last minute. It just leads to a lot of stress. Start them early, at least read over it, because then you can go to your lab, you can ask questions, you can go to the help sessions. Again, you can get lots of help. So the assignments are designed to take you a few weeks to do so that you're not working the whole night through and the whole day through. You want to take a few weeks, so you're doing a few hours, a few hours every day. So we have assignment 0. That assignment is going to be worth 5% and it's going to be due on Monday 8 p.m. in week 4. The purpose of this assignment is to help us understand where you're at in the very beginning of the course. It's also to give you some feedback at the beginning. So assignment 0, I will release it tomorrow with a note and an announcement about it. So, get excited. Assignment 0 is coming. Assignment 1 is worth 15%. It's going to be a little bit harder. It's also due Monday 8 p.m. in week 7, which means you have the flexibility week to relax and do your assignment. And it's going to be focusing on arrays and array structures, and it's going to be an exciting assignment, I hope. And assignment 2, also going to be quite fun, focusing on linked lists, 25%, and it's going to be due on the last day of term 1. So that's when you hand it in and you'll be like, sigh of relief, the term is done, now I have to study for the exam. But no, the assignments are also designed to be quite fun to do. So we're trying to come up with, exciting context, things that are quite fun to program as well. Now we've got late penalties on the assignments, 1% per hour apply, and that reduces your maximum possible mark. Again, the forum is a fantastic place to ask questions if you have questions about the assignment, as well as the help sessions and tutes and labs. Okay, so what have we got? Help sessions. This is quite important. I want everyone to know there are help sessions. We run help sessions. They get quite full. So please, if you need help, please attend a help session. We hold them using Blackboard Collaborate, and you can find the link on Moodle, which allows you to have one-on-one consultation with your tutors and time for you to ask individual questions, get help with specific problems. So if you've got, a chunk of code, you have no idea why it's not working, you really need help, this is the place to get that help. And if you really, really don't understand something, even if you don't understand how to start the assignment, it's still fantastic to come to a help session because someone can help you get started. So schedule will be up on the course website soon. We're just finalizing our schedule. They get very busy around assignment deadlines. So please, make sure you get help early and help often. We often have large waiting times. As you can appreciate, there are a lot of students in this course. So we do get quite busy around assignment deadlines. Sometimes you'll have to wait an hour or two for help. We're trying to correct that this term. Well, we're trying to make that time better by implementing the FastPass system. So hopefully it will help as well. So the FastPass system will basically let you register for a ticket to attend a help session. So that means we will reduce the overcrowding and also able to help more people as we go. So we don't have any physical help sessions scheduled this term, just online ones this term. Final exam. Okay, the expected workload will be around 3 to 5 hours in total. You'll be given a series of problems to solve in C, and you'll also be expected to read some C and show that you understand it, and also some questions covering programming ideas. So I will do a detailed exam lecture in week 10, okay? So don't worry about the exam. Focus on what's happening right now. We're going to do a detailed week 10 lecture about the exam with practice questions and showing you what kinds of questions you're going to get. But, if you are doing the problem sets throughout the weeks, if you can do the assignments, that's a really great indication that you will be able to comfortably do the exam as well. So the exam has 2 hurdles. Part of the exams, so we've got 2 competency hurdles. One is that you have to complete a question with arrays. One is that you have to complete a question with linked lists, and those questions will be marked in the exam, and you'll have choice. You can do one of those questions to pass the course, but obviously you do them all to get more marks. And to make you feel better, there's not many people that ever fail the competency hurdles. It's a very, 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 very minute percentage of people. And the reason we have the hurdle is to help you when you go on to other courses in computing, because you really need to know some of these concepts well, or you're going to struggle in the later computing courses. All right, total assessment. The labs are worth 15% across the whole term. Assignment 0 is 5%. Assignment 1 is 15%, and assignment 2 is 25%, and the final exam is 40%. So to pass the course, you must score at least 50 out of 100 overall in the course, and you must solve a problem using arrays in the final exam, and you must solve a problem using a linked list in the final exam. But more on all of this in week 10. We're going to have quite a detailed lecture about the exam in week 10, so do not worry about the exam. Special consideration, if during the term, and especially in this term, everything feels fantastic. I'm so excited to be on campus, but obviously, you can still get sick and you can't come to campus, or you may get sick and you can't do any work, and that's why we have special considerations. So if you are feeling unwell, if you need any support for anything that make it difficult for you to study, please apply through special considerations. And I've provided a link here to special considerations at UNSW because we can, we can give extensions based on special considerations as well. And again, if you have an ELP plan, please email it to me directly on my email, and we will put provisions in place to help you as well. Okay, supplementary exam. There is a supplementary exam. It is offered to students who are granted special consideration for the exam. Unfortunately, you can get sick at the exam time, and so this would be a reason that you would be granted a special consideration for an exam. So UNSW has a fit to sit rule. So if you show up to your final exam and you're sitting, or if you commence the exam, you sit the exam, this means that we assume that you are well enough to sit that exam, and you cannot apply for special consideration afterwards. So if you are not well, if you wake up on the morning of the exam and you feel like rubbish, please apply for special consideration as opposed to sitting the exam. It's going to be identical in format to the main exam, and it's held sometime in the period between the 23rd and 27th of May. So you must be available as well if you are granted a supplementary exam. Oops, went backwards. Okay, code of conduct. So I've kind of mentioned before, we respect everyone in this course, but this course in this university allows all students to learn regardless of background or situation. So there's really one rule that we have: please do not hinder anyone else's learning. Please follow respectful behavior, no discrimination, no inappropriate behavior, no bullying, no harassment, no aggression, no sexual harassment, and full respect for the privacy of others. Okay, so please just create a supportive environment where we all help each other and we all lift each other up, because especially after the last few years of the pandemic and everyone being online, a bit disconnected, it would be nice to have a supportive, connected term where we kind of lift each other up and help each other out as well. Plagiarism, the glorious plagiarism. Do not plagiarize, please. In our welcome video, for those that watched it, we did do a little spill about plagiarism. Basically, plagiarism is the presentation of someone else's work or ideas as if they were your own. So please do not do that. It can be considered a serious academic misconduct, and there are serious penalties for academic misconduct. We do run plagiarism checks on your assignments. So we do check for plagiarism because, also if you're plagiarizing, you're not really learning anything either. And if you ever feel like you are struggling, you are going to plagiarize, please let us know, because there is no shame in it. Everyone, I think, has felt that way at some time, overwhelmed. I don't think I'll get it done. I'm just going to copy someone else's work. Please don't do that. Get in touch with us. We can help you. We can help you get started, and we can tell you, we can help you, we can actually help you not plagiarize, to actually do your own work and to learn something as well. Okay, so collaboration on the individual assessments, like assignments, is considered plagiarism. Someone's asked, what is the maximum plagiarism rate? So plagiarism comes in many forms. I like to educate people first, but if you have seriously copied everything from someone else, we refer you to a special place that interviews you, and you can fail the whole course. Or you can even be suspended from the university, depending on the level of plagiarism. So plagiarism in academia is considered to be a very serious offence and a very serious case of academic misconduct. It's very difficult to unknowingly plagiarize. I know it feels like, oh, this can happen, but it's actually very difficult to plagiarize without knowing. So the chances of that happening are very, very, very minute. Okay, so you can still talk to someone, about the assignment, but you can't talk about code. But you can discuss like the algorithm that you're going to be using, or just discussing, you know, how you're going to perhaps solve things, but you can't actually talk, you know, talk code, show code, use code. So the internet also has a lot of resources that you should learn how to use. If you are using anything from the internet, you can use 1 or 2 lines of code. If you use 1 or 2 lines of code, you have to credit the source. So just like in an essay, you have to reference who the author is that had that idea. The same thing here. If you use a piece of code that came from something like Stack Overflow, you really want to reference it. No collaboration at all on individual assignments. So your submissions have to be entirely your own work. Don't use other people's code. Don't ask someone else to solve problems for you, and don't provide your code to other people. That's also really important. So don't provide your code to anyone else as well. So someone's asked 2 or 3 lines of Stack Overflow encounters plagiarism. You have to acknowledge them. Usually you wouldn't count that as plagiarism, but you have to acknowledge. Okay. Yeah. So please don't stress about plagiarism unless you're actually copying someone else's code. It's very difficult to plagiarize. You know, when you're solving, we all actually think in very different ways. We all write in very different ways. So it's actually very difficult to do. Okay, so it's all the assignments are individual. You can talk about the assignment in general, but you should not be sharing any code of the assignment. Okay. So as I was saying, at best you'll lose the marks for the particular assignment. At worst you'll be asked to leave UNSW, so the penalties range quite a bit. But you won't learn anything that you paid all this money and time to learn. So use this wonderful opportunity of being at university to, you know, throw yourself into these courses and actually enjoy the learning as well. You can absolutely talk about the assignments with your tutors. We strongly encourage you to talk about the assignment with your tutor. In your tutes and labs, and also in the help sessions, you will come in and you will show your code to your tutor and they can help you find issues with it as well. So absolutely. Okay, so if you want more information, places to contact. Sorry, I was like looking at the chat as well to see if there's anything on the chat I should address. Okay, so we've got our course webpage. That's going to be, bookmark that. That's going to be your one place to get all the resources. The course forum, bookmark that, because that's going to be, I swear I had a link to the forum. Oh, it was on an earlier slide. Please make sure you can log into the forum. Please make sure that you're there. You can ask questions. It's a great place to ask questions and to get answers as well. Recorded lectures, replay YouTube streams or via Moodle. You can do one-on-one more information or help. Ask your tutor during lab sessions or attend a help session for any serious issues. Thank you so much for providing the forum link. I appreciate that. Thank you. Tom wins this time. Tom beat Shrey. Yeah. Shrey, 1 mark against you. You were too slow. Okay, so any serious issues, please email us at cs1511@CSE. The nucleus for any enrollment issues, and CSE Help Desk. I've provided the link for that. Someone's asked, is it worth taking notes during lectures? No, because normally in a lecture you'll be coding alongside me. So that will be kind of like your notes, and also it'll be a great way to stay awake, because I find if you're just listening to someone speak, it's very hard to stay awake. All right, student support. I thought you can get this slide on the course website as well. So please, if you need help with anything, I've provided a list of resources that you can use to get help. If you need, university can get very intense if it's your first taste of uni as well. Things are very different to the way they were at school. Some of you are just starting out. So please, don't suffer in silence. I always say that to my tutors as well. Do not suffer in silence. I think that's like I should get it tattooed on me. Please get help. We're here also to help you with your, academics. And then there are other resources that the university provides where you can get help. You can get mental health help. You can get anything to do with uni life, uni pressures. If you need to report sexual assault or harassment, I've provided also a place to do that. If you need educational adjustments from the Equitable Learning Service, I've provided a link for that as well. Academic and study skills, we also have places that can help you. If you don't know how to, I don't know, write an essay, that you can go there and you can get some extra help. And special consideration link is up here as well. So please, if you need to, just load up this slide. It gives you all the links in one place. Okay, I think this is my slide before the break that we take, and I really want to drive this home. Okay, so learning is not easy, okay? It is hard. When you're learning programming, it's like learning a secondary skill. It's not natural, it's not intuitive, okay? It's not learning how to speak, which just happens, when you're a small kid, you just learn how to speak, that's it. You don't really put much effort into it. Programming is not like that. It's a secondary skill. It means that you learn it very slowly and you have to make conscious and deliberate effort to learn it. It's not magical. It doesn't happen overnight. You have to practice. You have to solve lots and lots of problems. You have to build up your knowledge base and the big library that you have in your brain. You have to work your memory as well. So please don't feel disheartened if you don't understand something first go. That is perfectly normal. Try and try again. Get help, ask us to explain it. And sometimes maybe I will explain something and it will not make any sense. You'll go to your tutor will explain it. It will still not make any sense. And then you'll go to a help session and a third person will explain it. And the way they've said it or the way they've just mentioned something will make absolute sense. So please, get help. Let us know if there's something that's just not making sense. And we can help you and explain it in different ways. Make sure that you attempt, all the 1 and 2 lab questions if you can on all the assignments, because working through these problems will help you to build that understanding of how to solve similar problems. And it helps you to learn how to use code as well. So you're going to have to put in some work. I'm sorry to say, but I hope that you are going to have fun whilst you do it as well, because, coding is really fun. It's really fun to solve problems. So it's hard at first. And then I think, it becomes very intuitive after you go over that initial hurdle. All right, I keep going backwards and just all over the place. Okay, let's have a little break. I like to do little riddles when I do a break. Feel free to try and solve them in the chat, or feel free to, stand up and stretch your legs, or feel free to, have a little stretch, have a snack, whatever works for you to have a break. Okay, let's have a little break. So we'll do 5 minutes. All right, we're back. Back from a break. No, I just want to sing We're Back. But no one wants to hear me sing, so I won't. Okay, so I think, yeah, lots of people are solving it really nicely. Someone wants to get a measuring cup. I love it. Someone wants to play Hangman. Amazing. Oh, and someone's actually playing Hangman in the chat. I feel like it's world time or something. All right, let's get back into it. Because then we'll get through it and we'll get our first taste of exciting code. All right, what is a computer? What is a computer? What do you guys reckon? What's a computer? Most of you have had a computer for a very long time, I reckon. You have to have them in school now too. When I was at school, we had to write things still on paper. No one had a computer. There were 2 computers in the whole school. Okay. Something that computes. Great definition. Yeah. A thing I used to play games. I reckon, yeah, lots of people love to play games on the computers. It's a very smart machine. No, it's a very silly machine. Sometimes it's very smart. It's a very frustrating machine. A device that takes instructions, does what it is told. Shrey, what is a computer? My worst nightmare. Yeah, Shrey and I had a conversation today that went something like, that we're all, it's all done. And Shrey said that the worst thing that humans did was invent computers. And that was just a moment, because usually we do love computers. Let's have a look. Oh my gosh, lots of, machine with input and it spits out an output. And a lot of processor to execute commands. Yeah. Okay, so a computer really, it's an ultimate tool because you can configure it for a whole bunch of purposes. You can do so many things with a computer. People have said they want to play games on the computer. And people have said that, they do things, they compute things. You can write essays. You can do so many things on the computer, but basically a key element and some trivia. I've moved that some trivia where it doesn't have anything. I've moved it to the back slide so you can find it. It's all about the birth of computing. So some key elements is that it has a processor to execute commands and it has a memory to store information. And we'll talk a little bit about why those things are important. It's really just for your understanding of what we're doing. It's not really like an examinable thing. I've also attached some trivia for you. It is about females in computing. Because computing used to be full of females until the personal computer came about, when it became a male-dominated industry. But the trivia, there's a beautiful article about all of that at the end of the slides if you're interested. Okay, what is programming? And we talked a little bit about what is programming. And so basically when you write your programs, you provide a computer with specific instructions to solve various problems. And we use specific languages to write those instructions in. And you probably know that there is a lot of different coding languages. And in this course, we are learning C, which is a really exciting language. I know maybe not everyone feels that way, but I feel that C is a great way to introduce you to computing because it also gives you a little glimpse of what the computer is actually doing. So it's like a high level, low level kind of language, which means that you have to think about memory when you use C, and you have to think about a whole bunch of other things. So what it does really nicely is, as your first language, it kind of makes you think about what the computer is actually doing inside. Okay, so at the core of it, problem solving is really all about problem solving, right? At the core of it, coding is problem solving. So you have to be able to solve a problem. It doesn't really matter what language you write the solution in. The hardest part is solving the problem. So what is the logic that I will use to solve a specific problem? And then you can attach really any language to it. And once you learn one computing language, the concepts are very similar. You might have to learn some different syntax things, but data structures are very similar. The same. You'll learn all about different data structures here, and you'll implement them with C. And then then we'll kind of, you'll go on in computing and you'll do other things and perhaps learn other languages, but hopefully this course will be the one that starts it all for you. So when you're solving problems, you don't usually get it right the first time. And that's okay as well. You will have to make many mistakes and sometimes go through many iterations before you get it right. Mistakes are good because anytime you make a mistake, it's another reason to learn something as well. So, and it's another reason to see what went wrong and to understand something better as well. And sometimes you learn a bit more from mistakes than you do from just getting it right the first time. Okay, so what is an operating system? And the reason we ask this, and now I'm on the wrong side. Let me switch sides. Let's switch sides. Oh, I've disappeared. Oh, I'm just not there anyway. There we go, I'm back. So an operating system is, sorry, I'm lecturing from this place for the first time, and so I'm just getting used to the bunch of equipment that surrounds me and trying to stand still, which I'm not doing a very good job of. I keep rocking back and forth. Okay, so what's an operating system? It is something that sits between the user and the computer hardware. So it's something that sits in the middle and helps us. Someone has said, it helps us to execute user programs. It makes solving problems easier. And it's basically the middle ground between us and what the computer hardware is doing. And so in this course, we are going to be using Linux. Who has heard of Linux or who uses Linux in this chat? Who uses Linux? Who's a penguin? How many penguins have we got? Yay! Oh, quite a few. Oh my goodness, lots of Linux. Oh, Windows 10 Supremacy. Oh, I'm not sure about that. Not sure about Windows 10. Yay, Linux. Yeah, a few people have heard of it. Basically, Linux is a Unix-based operating system. It's open source, it's more reliable, it's lightweight, it's faster, and it's more secure. And because it's open source, it is also very much free. So it has a lot of things that you can do that gives you the control. And yeah, so there are camera issues. This camera really, really hates me. Whoever says that I keep becoming very blurry, I'm sorry. It hates me. Tom stood in front of the camera for like 10 minutes and it did not blur him. The camera literally just hates me. So apologies. You'll just see a big blur half the time. Okay, so Linux, we are using Linux. What is Linux? I think it's time to go and do something to wake us all up. And, you know, this part of the reason, and, you know, people don't like me for having this opinion, but I am a Mac user and Mac OS is built on top of Unix basically. So that's why Mac OS was a lot more stable than Windows when it was first, you know, taking over the markets. But that's part of the reason. Unpopular opinion, or popular opinion if you like Macs. Okay, let's have a look at what is Linux and what is a terminal. Oh God, I've dropped a pen. It's really warm in here. Okay, so let me close my terminal window. For those of you that have not seen, have not been in the... oh, lots of vomits for Macs. Oh, well, that's okay. Okay, so for those of you that have not yet been in the lab, you will, when you go into your TLB, tutorial lab, because it's called a laboratory time, so when you go into that space, your tutors and the first lot of problem sets are not really problem sets. They're basically a way for you to get started. So you will install a Tiger VNC client, and then you will run the virtual lab that CSC has from it. And it will open up, and I should have really done it from scratch, but I didn't prepare that. I'm sorry, I didn't think of that. So you will see this beautiful window after you set it all up. Follow the step-by-step instructions that we have. And what we will be doing is we will be running a lot inside terminal. Okay, so we're running a lot inside this lovely terminal window. And so when you install everything, and when you follow the 1511 setup instructions, so you'll see that you'll type in something like 11511 setup. It will run a whole bunch of things for you. Mine will not run anything. There we go. Mine's run something for as well. It just took a little bit of time. But it will set it up for you with the way that we want you to, well, with the way that we think is the most sensible way when you're learning computing. So you don't even have to make all of those settings. As soon as you run that command, when you go into terminal, you will see that it will set it all up for you. So it will set up the colors, it will set up the editor as well, and it will prepare you for being able to do lots and lots of fun programming as well. So we start you off from using a text editor, a very simple text editor to do your code in. Okay, and after that we are going to, so there's, you don't have to follow along with me here. You don't need to follow along yet. Don't worry. You will need to follow along in later lectures. A lot of this stuff you will do in your tutorial and your lab. So there is, so someone said that gedit is gross, or gedit, but it's okay. We set it up with nice colors for you. And you can get pretty colors as well on your terminal. There you go. Shreyas provided the command. So if you type in 1511 colors, and we have all of these instructions in your, if you look on the website, it will actually let you configure your terminal to use colors. So it will be so pretty as well. All of this is done in the lab as well. Okay. So let's have a look. Okay, so what do the basics looks like? We really want to have this text editor called gedit, and I'll show you how to open it as well. And we want to have a compiler as well in which we compile our code. And I should really explain what a compiler does. So what a compiler does is it translates. So when we write our instructions in C, what we're really doing is we're writing formal human readable C, okay? It is not a language that the computer can really understand. It's not machine readable. So the compiler takes this nice code that we've written that we can understand, and it translates it into machine readable code. And what it does is it produces a file that we can then run, that the computer can understand, and it does whatever it is that we want it to do. So you're going to use those things, but we provide all of it. All of it runs inside this virtual lab that you load up. And so it makes it easy. You really just need to run the virtual lab on your computer, and then you can do all of these things. Okay, so let's have a look. I don't know, who feels like writing Hello World? That's always a great place to start, I feel. Oh, I haven't really done any Unix. Should I do Unix? Yeah, let's do Unix. Sorry, I'm going to take a step back. I've gone too fast. I got too excited. I was like, let's code. But we shouldn't code. First, let's look at Unix first. Okay, I'm going to explain some Unix things first, because otherwise you're going to be a bit lost without it. Okay, so I'm going to clear this. So if you see in the lecture, I will write clear a lot. What it does is it just cleans up my screen so that you can see what's going on. It's still all there if I scroll, but it just moves it down so that the screen is clean and you can see what's going on. Okay, so there's a few commands that you will need to know in Unix, and all of these are in the lecture notes. Okay, so I've popped all of those down. Any useful commands are popped down inside your lecture notes. Okay, so what are some useful commands that you need to know when you're using terminal? So using terminal is really, most of you are used to using graphical user interfaces where we would have a folder structure. So we'd have a folder structure like this, and then it would have all of our folders inside there. Now these folders are called directories, okay? So if I want to see what directories are inside my main folder, okay, I'll type in ls, which lists all the files in the current directory, okay? And if you see, they will all be the same as here. And I really should have cleaned up some of this before I did that. But anyway, I did not. So enjoy this really messy file structure and 70 files called tab, test, something, who knows. So basically, you can see that even 22T1 is a directory here shown, and 22T1 is right here. So a folder is really like a directory that you have on your terminal. So if I press ls as the command and enter, what happens is that it lists all the directories that I have inside my current directory. So it lists all the folders inside there. I can also make a new directory if I type in the command make directory. So I'm going to mkdir, make directory, and let's call it welcome with capital letters so we can see it being made. So now if I list out all the directories, you'll see that I should have a lovely directory over here called welcome, because I've made a directory called welcome. And if you look inside my folder structure, if I look on the graphical user interface, that folder is still there. Who knows where it is? No one. Here it is, and it's here as well. So I've basically created a new folder by doing that, or a new directory. Now what happens if I want to go inside that folder? So what happens if I want to actually click through and go inside here? For that, I use the command cd, which stands for change directory. And I'm changing directory. I will say where I want to change the directory to. So I'm going to change a directory into welcome folder. And if I click that and I'll go ls, it will give me nothing because the directory is still empty. So let's say I would like to find out, where on earth am I? What am I doing? I'm lost because I'm only directed by, no graphical user interface. Sometimes I need to see what is my current working directory. So I can type in, not there. I can type in pwd, which says print working directory. And what it does is it prints out the directory that I'm currently in. And if you note, that is exactly where I am over here as well. So the structure is exactly the same. So I can do things back, so I'm using a command line driven interface to control the computer. So if I want to go back up into my structure, I can do a few things. If I do cd, which is change directory, and I do 2 dots, that means go up one directory structure. So now I'm back inside one directory structure. Okay, so cd ... moves me up one directory. And someone said, what's a directory? Yes, so a directory is like a folder on your graphical user interface. That's what a directory is. It has a whole bunch of files in it. So think of a directory as a folder that has a whole bunch of files or other folders inside it, and that means it would have other directories. So in the command-driven interface, it's a directory, and in the graphical user interface, we often call it a folder. Okay. All right, so let's, what are a few other commands that we want to do? Let's go inside our, I keep typing in the wrong place. Who's lost? A few people are lost. Who's lost? Let's run a poll. Who's lost? Someone's saying your tutorial lab will be able to help you. So, yeah. So can we please link the instructions to the tutorial, someone in the chat, so that the students can see how to set up the Tiger VNC. And someone is asking, how do we open a terminal? Okay, let me close this one and then I'll open it again. Okay, so when you run your setup and when you install the Tiger VNC, you're going to get something that looks like this over here. Okay, you're going to get this exact window. And your tutor will run over this also in more detail in your tutorial and lab to help you get set up. Okay, so don't worry. You're going to get more help with this. The terminal window is located over here. This icon over here is, oh, I can use the pen. Here we go. This over here is the terminal window, okay? This is the web browser, but you don't really want to run a web browser often around it. And this is your graphical user interface of folders. So up here we have the folders, and this one here is the terminal. Okay, we're going to, there's a lot going on in the first lecture, okay? Don't worry. You might be a little bit lost. You will come back. You need the first tutorial to set this structure up, and then you will understand what's going on a lot more. Okay, so when I want to do something in my command-driven interface, I open a terminal and I work inside the terminal to do things. Okay, so I've now circled the terminal, and what I'm going to do is I'm going to open the folders. Didn't mean to open another. I'm going to open the folders as well so that you can see what it is that I'm doing. Okay. And I'll go through those commands again, because actually we've got a bit of time to go through those commands again. Okay, and so now remember that we've got up here, I've opened the terminals, I've opened the folders. Actually, these two are equal. So terminal, I'm writing on the equals folders, okay? So this one is your command-driven interface. This one is the graphical interface. So folders are over here. I've got them on this side, and the terminal is over here. Okay, so inside the command-driven interface, instead of calling it folders, we call it directories. Okay, and the reason for that is because that is really what it used to be back in the day, and command-driven is how it all started. Graphical came a long time after that. So basically, each one of these things that you see here is also, so this is a folder here, this is a folder here, this is a folder, this is a folder, this is a folder, and this is a folder here. So anytime I enter into any of these folders, I might see more folders or folders upon folders, or I'll see other files. Okay, so what that means is that I've got this kind of structure that I have inside my folders over here, the same type of structure I have on the command line interface. But the only way to show that is to, you know, to have it written in words as well. So I'm going to just erase this so I can write and you don't get lost into what I'm writing. Okay, so now if I'm actually doing, let's do, what should we do? Let's do making a directory again, or should we list? Let's list the structure. Okay, ls is the command that we list whatever's in our directory is. So what it does is I'm sitting inside this directory here, and if you have a look, they're exactly the same as this here. Well, slightly different, but don't, it's only because I'm in this home. So what happens is it shows me all the different folders that are sitting inside my directory, and you can see that they match up here as well. So 22T1 is over here, that's the folder. I've got something called desktop, and the desktop is over here. I've got something called documents, the documents is over here, and so on and so forth. So this is really one and the same, but we use the terminal interface inside when we're doing our coding stuff, because it's much easier to run things and compile them. Okay, so let's see. So that was listing a directory. Now let's see how we do. A new directory. So I've made a directory called welcome. Let me do another directory, and I'm going. So the command is mkdir, which stands for make directory. Let me erase this. And then you say what directory you would like made. So what would you actually like to call this directory being made? Okay. And let's do, what should we do? Welcome to. So I've made a second folder called welcome to. So now if I list out the structure of my directory, you will see that I have a welcome, which I made before, and I have a welcome to in here as well. So now I've got those two directories, and it would have also appeared over here. So I have the welcome folder, which I made the first time, and I have the welcome to folder, which I made the second time. Okay, let's say I want to remove this directory. Let's say I want to remove the first directory. The command is rmdir, and then I type what directory I want removed. Okay, so now if you saw, it disappeared from here, and if I list out my structure again, it's also disappeared from here. So the commands that so far we have learned are, okay, ls, which lists all the different structures. That's what lists everything out. We've learned make directory, and we've also just looked at remove directory, which is rmdir. Okay, so what happens when we want to go inside a directory? So when I want to click through in the folder, so if I want to go inside here, so let's say I'm going to do a cd, which means change directory. So I'm going to use the cd command, and then I'm going to tell it what do I want to change the directory to. So cd welcome to, which means I would like to go inside this folder. Okay, so I would like to change my directory, or I would like to change my folder. I would like to change it to welcome to. So let's press enter, and as you can see, I've gone inside this welcome to folder, and it doesn't have anything in it. So how about I make another directory in here, and I'll call it, okay, and so now you'll see this folder appear in here once I click enter, and as you can see, I've made a directory in here. Okay, to go inside, now if I list out the structure, you can see that I have a folder, one folder inside there, and that folder is 21511, and that folder is in here as well, 21511. So it's exactly the same. You just have to get used to only using this command-driven interface. So let's say I want to go into this new folder that I've made. I'll just change directory to it, and I'll go into it, 21511. So now I'm inside this welcome, and I'm inside 21511, which is exactly where I am here, welcome and 2511. Okay, so now let's say I want to go back out of here. So I want to go one level up. So if I list the structure, there's nothing in there to show. So let's then go to one level up. So I'll go cd ... which means change directory, one structure up. And it, as you can see, it moves out of this folder and back into the main folder. So now if I list the structure, it has this folder in it, so I'm sitting over here. And if I change the directory again one up, then I'll go back into my main folder where I'm sitting. So that means I've gone back in here, and now I'm sitting in this one with lots and lots of different files and lots of different stuff happening. Okay, so that's really doing all our lovely directories. And then let's say I'm going to go back into them. So welcome to, and then I'll go again. And let's say now I'm like, well, actually, I don't really know where I am, even though it says here where you are. But if I want to know where I am, I can use the command pwd, which stands for print working directory. So where am I working right now? It will print out my path. So it will print out which path I'm here taking. So this is my main path. So what that means is I've gone in here, and now I'm just sitting in this section over here. Okay, and there is, obviously, that's doing it one step at a time. There is ways that you can go straight up, fly up to your home directory as well. So if I just press CD, it will take me all the way to the very, very top as well. So, okay, let's have a look at a few other commands. I hope I'm not overwhelming you yet. That's a lot of commands, and I always think, well, there's a lot of research that command-driven can be a little bit overwhelming at first, and then you remember a whole bunch of commands that may or may not be wasting your memory. I don't know, I often still look up commands. I just remember what they start with, and I'll have to Google what command I actually need. I just know that I can do it, but I can't remember the command. So, it's perfectly okay to not remember commands in command-driven interface. You really just have to remember those 4 or 5 basic commands that you can move around and do things with. So you want to do cd, to help you move around directories and move around folders. You want to be able to make a directory, and you want to be able to remove that directory. Some other things, though, that you might want to do is copy some files, rename some files, and remove some files. So I think we might, and someone's asked, yes, you do go over these commands in the tutes and the labs. Absolutely. Don't worry, you will go over all of this stuff. And this is not a language. This is using commands to move around a command-driven interface, so moving around in your terminal. So instead of doing it on a graphical user interface, you feel like you need to inflict some pain on yourself and test your memory skills. So you're going to do it on the command-driven interface. Okay, so yeah. Okay, so let's remove some stuff now. Okay, I'm going to list the structure. So I'm going to use the ls command, and let's say I'm going to go inside this welcome to. Okay, and I think I might make a file. Should we make a file? Let's make a file. Why not? Or I don't know if, overwhelming or not. Can't decide. How is everyone feeling? Overwhelmed, or is everyone feeling a little bit more in control? Can you give me something on the chat to let me know? Not too bad. Okay, people are still in control, a bit more in control. Okay, great. Let's make a file. Let's do it. Let's make a file. You know what? I might do, your tutorial and your lab will go over all of this. Okay, so when you go inside your laboratory and when you go inside your tutorial, we will go over all of this again. Okay, so don't worry. Okay, don't worry. And sometimes this stuff just feels like, you know, I don't know, just magic, but it's not magic. I promise. This will all, by week 2, you'll just be like, you know, punching commands in, just feeling like an absolute hacker hero. So don't worry. I swear it all comes together so quickly and becomes quite natural. Okay. Let's make a file. Okay. Oh, someone's asked a great question. Does capitalization matter? It does indeed. Yes, it does. So that's a really great question. Well done. Someone's asked, why use commands over the GUI? It's really so you can feel like you're just the hero of programming. No, it's not. I mean, somewhat it is. Sometimes when, I'm on terminal and I'm using these commands, I feel like I'm just, brilliant. I'm the best computer science. No, not quite. But it does give you a lot more freedom. So, GUI is much easier and everyone can use a GUI, hopefully. That's the whole point of it. When we use terminal, it allows us to do a lot of things that we can't often do on the GUI. So it gives us a lot more control over what the computer is doing and how a GUI is a graphical user interface. So this is a GUI over here that lists out the folders and actually shows you everything, in a graphical format. Now, when we use the command line, we have a lot more freedom to do a whole bunch of things that we wouldn't normally do. Yeah, so that's really why we use the command line in this course. And when we try and compile things, we need to use a compiler to translate our code to a machine-readable language. And we really need a command line to do that. So that's why we kind of do a few things to get you introduced to this command-driven interface and to start doing this type of, sort of computing as well. This is not considered programming, no. When I was a kid, this was the only way that you could move around computers, is the command-driven interface. So it's not considered programming. It's really just it's using the computer. So I am using the computer to create structures or to see files and to do things as well. So you can do a lot of things on there. So it's not programming. We haven't started programming yet. Someone's asked, do we have another command to jump through more folders? We do have another command. So I'll show you if you like. So If I go up again, so let's say I've got this welcome and then it's got this 21511. What I can do is I can say CD, and should I give you the shortcut? If I press tab, it might finish my word for me. Welcome, so it's chosen the folder name, and then I can do my next folder name that's in there. And what it will do is it will jump into wherever I need it to go. So I can give it like a full spacing of where I want it to go, and it will take me there. But you will find yourself doing a lot of ls. You know, I feel like all I do on command line, I change a directory and I'll do ls, because that's the only way to see what all the folders are that you may need. So you'll be doing a lot of movement ls, movement ls, movement ls. That's sometimes I feel like that's, you know, I'm the ls queen. I just have constantly listing out my directories. Okay, so you can so tab is not autofill, but if you start out writing a name of a file or a directory, if you press tab, it can finish it for you, depending what you have going in the directories. It's much easier. It's called like a little bit of laziness as well. I'm very good at that. If you've ever noticed as well, if I press the up arrow, it gives me the last command as well that I've put in, and then if I press it again, it gives me the command before that, and so on. So pressing the up arrow is also a useful shortcut that you will have. Okay, how long? 5:30. Not bad. We're doing pretty well. Okay, timing is good. I'm just trying to think, we were going to make a file and then I stopped. I might combine this making a file with the first taste of programming, and then I'll move that file along, because I think that will be really good. Okay, let's do that. Okay, so don't pay attention to the command I'm putting in now, because I'm just moving into a directory that you will be able to see. So don't worry, you will not have this directory, but you can follow the link on our website to see what is sitting inside this directory. So I've traveled to this directory here, which doesn't matter, but then I listed out what's inside it, and it's got this file called helloworld.c. If you go on our website and you type and you press on the lecture code on the button for that, it will take you to a browser window that has this file in it, so you'll be able to see this file. And that's how we're going to work throughout the different weeks. We're going to be, you can see all the code that I write. Today is obviously going to be a very simple piece of code. It's, you know, every language you always start by saying hello to the world. Where did it start? Trivia quickly. Someone trivia me. What year was the first hello world written? And also I love, there's a picture of, you know, no, I'm not going to, I love trivia. So, yep, sorry. 1972 was the first hello world. So imagine that, how many years later we're still helloing to the world. And it's kind of become the quintessential thing you do when you first learn a language. If you can do hello world, you are winning. Okay, so as I said before, someone got 200 BC. Maybe there was like a cave carving that said hello world. Okay, so when we are going to start our programming, we are going to start our programming inside something called gedit, and gedit is a very simple editor. Okay, so it's basically a text editor, and the reason we start you out in a text editor as opposed to a whole a development module like VS Code, which you might hear about, and some of you might be using VS Code as well, is so that you can focus on the simple code to start with. And if later on in the term you want to switch to be using something more complex, we can help you with that as well. So if I want to open something with gedit, I will type gedit, because that's the command that opens up gedit, which is the name of the text editor. And then I will type in the name of the file that I want to open. Okay, and in this case, I know that in this directory I have a file called helloworld.c, and that's the file that I want to be opening. So I'm going to say gedit helloworld.c. Okay. Now there is something special that I do at the end of it as well, and that's me putting an ampersand symbol. and I'll show you why. So let's do it first without the ampersand symbol. So without the ampersand symbol, I'm going to open this, and it opens a gedit command. The reason it has something in it is because I wrote this before this lecture to say hello to you. But what do you notice? If I go back to the terminal, I can't really do anything else, okay? So if I open my window without the ampersand, it means that I lose control of the terminal. And that's a problem, because later on you're going to try and compile things and you're not going to be able to run anything in the terminal if you have this window open. So if you do this, which is very common, sometimes you type it in quickly and you press it and it opens and I forgot the ampersand. So then all you have to do is close this window and you get your command back off the terminal. Okay, so basically then if you run it again, so gedit, I want to open hello world.c, and I'm going to pop the ampersand now. Ampersand is the and symbol for and. So if you do shift and 7, that will give you the ampersand. So if I do that, what you will notice is I will now have a window, but I still have command of my terminal over here, so I can still do lots and lots of things here. Okay, so basically the ampersand allows us to do both things at the same time. So I can see everything going on here. Now I'm going to erase this. Oh, because otherwise it's okay. So how exciting, we've just opened up our first file, and we can see this lovely file, and let's talk about this file and what's going on here. And let's say, okay, so inside here right now I've got a hello world.c. What happens? I opened a file that already exists. What if I want to open a file that does not exist? What if I want to make a file? Okay, all I do is if I create gedit, okay, and then let's say the name of the file I'm going to create is going to be hello.c, and I'll put the ampersand again. What it will do is it will open a file called hello.c, and as soon as I save it and I list the structure, I'm going to see that there is 2 files in here now. Okay, so you will notice that one of them is in green and one of them is in white. Don't pay attention to that. It's because I am sharing Hello World with you, so it's got different permissions to hello.c. I'm not sharing hello.c with you because that file is, but it now gives me an opportunity to remove a file. Okay, so let's say that I want to remove a file. I use the command rm. So if you remember, to remove a directory, we used rmdir, so remove directory. When we remove a file, I just say rm and I'll say what the file name is. And you have to be in the right folder, so where that file is, to remove it. So I'm going to remove it, and now if I ls and list the structure, I only have one thing in there, which is hello world. All right, so let's see what happens then. Okay, so let's do our first file. How exciting. Okay, now as you can see, the top part of my file is currently in blue, and these weird things over here precede it. You know, what's going on here? It looks like madness. Okay, so what this means is anytime a statement has these 2 lovely slashes, I forgot what they're called. Oh my God, I had a brain fart on what a slash is called. So anytime you have those 2 slashes, it means that you're making a comment. Okay, what that means is that comment is only readable by a human. So when a machine compiles your code, it will skip over those lines and it doesn't pay attention to them. So when we have our code, the first thing that we do is that we have something called a header. Okay, so this part of the file is called a header. And what that means is that every program we start by telling a person who might be reading our code what on earth this program does. So the header usually says what this program does. It says our name and perhaps the date. And for you, might even say your ZID. And we will provide you with examples so that you're able to see what it is that you need to say in the header. Now, so part of having good style, so part of doing good programming and writing nice code, you know, whenever you were writing essays in class, you were probably told, you know, keep your writing neat, use paragraphs, do it so that it's easy for someone else to read. So code is no different to that. You need to make your code easy for someone else to read. And part of that is saying, what is my code doing? What is the purpose of this program? So that someone doesn't have to read the whole program to understand. And then after that, you can start doing some programming. All right, so let's say that we have our lovely first file. So let's see what we can do about it. Let's learn. Okay, so this is our part that we do for humans. And those 2 dashes is what it means a comment. You'll see when you're using gedit, you'll see that any comment turns blue so that you know that something is blue. Okay, let me erase. And we'll do our next bit. Okay, when you start programming, you will also have to do one more thing. Okay, so there is one more thing that you do. And almost every C program you will write in this course will have this one line, okay? And this one magical line is going to have a hash include, and I'll explain it in a second. I'm just going to write it out, make it turn, well, I don't make it turn. It will turn pink when I close that bracket, and now I'll explain what this line means. Okay, so this lovely line we write almost at the beginning of every program that you will do, especially in this course. It will be basically everywhere. Oops. And what does it mean? Okay, so basically what this is saying is it's asking to include something in this program. The hash include says to the compiler, please grab some code from somewhere else that I want to use in my program. And please add it to this structure. And this over here is where I would like to grab that code from. So I would like to grab it from something called stdio. And in this case, it means standard input output library. So the reason you use this one all the time is it allows us to use some pieces of code without having to write them ourselves. So there is a whole bunch of standard libraries in C that we borrow code from, which means that we don't have to write it. It's already been written. And usually those chunks of code are ones that you use all the time and reuse all the time, which is why they became standard libraries. So in this case, the standard input output library, it allows us to make text appear on the screen. And it will also allow us to take text off the screen, but we're not doing that today. We're only going to make text appear on the screen. So let's have a look what happens next. Okay, so we've included our library. It's all very exciting. So now we're going to write our code, and this is part of the sort of structure that you will have for your coding as well. Okay, so we've included our standard input output. So now we're going to actually write a little function. Okay, and you will be like, what's a function? What is she talking about? More on functions is coming. I'm going to use that word as a bit of a magic term right now, but I'll explain a few things about it, but not in detail, because that is coming. Okay, and I'm going to write a whole bunch of things that are going to scare you. Maybe int main void. Maybe sometimes you've seen it. You're going into the void. No, you're not. Let's talk about what all of these mean. Okay, so I'm going to write a function. Okay, and that function is going to be called main. Now, a function is basically a block of code that has a set of instructions inside it. Okay, so think about it like that. And the computer and the way that we read the code is line by line. It executes the instructions. So it goes in consecutive order. I was trying to thinking of the word consecutive. So it just executes line by line. It goes from the top line downwards and it executes what we have. So we will cover more about functions in the lecture, but basically when you have your top line, it specifies three things for a function. It specifies an output, it specifies the name of the function and the input. So the way it goes is I've said that the output is going to be an integer, and more on that coming on Friday. Don't worry. And I'm giving it nothing as input. Okay, so void just means that nothing is going into this function, and I'm calling it main. So what it means is the output is going to be int, so it's of type int. That means your output coming out of this function is going to be an integer, and I'm going to give it nothing, okay? Because I'm mean and I don't want to give it anything. Okay, so now we're going to have a few things. We're going to print something out to our terminal, and the command for that is printf. Okay, so I'll just type it out and then I'll explain it part by part what all of it means. Okay, so oh gosh, okay, you might have heard some jokes about semicolons, about coders and semicolons. If you see any good memes, share them. This is the semicolon is the semicolon. Sometimes you'll write a lot of code, you'll forget one semicolon. And nothing is working. Very frustrating, the semicolons. So in C, we finish our statements with semicolons all the time. And let's have a look about what we've written here. Okay, so anything between these curly brackets, here, that's going to be the set of instructions that I'm following. This command here, printf, is the command that I borrowed from inside this studio, stdio. So that I borrowed from inside standard input-output library. So what it means is that I don't have to write code for printing something out to terminal. That code already exists, and the command for it is printf. So anytime I want to print something out to terminal, I would just use the command printf, and I don't have to really do anything else. When I use the command printf, I use a certain syntax to print something out, okay? So I'll have an opening bracket because the actual function is printf, and then in brackets is whatever is happening inside it. So these two apostrophes here, they are saying what text I want to print out, okay? And then a few of you have pointed out, what on earth is that ridiculous new thing? Oh, I just gave away what it is. I'm sorry, I got overexcited. What is this ridiculous \n? The \n stands for new line, okay? It means that I want, when it prints, hey, I want it to go to the next line. And we can see in a second what it does if I don't do that. And we can see what it does when we do that, okay? So let's have a look. Actually, I should have erased all of this now. And now we're going to use the compiler as well for the first time. I'm not going to return, I think, for a bit. Okay, let's use a compiler. Okay, so let's save the file as well. So, because if you don't save it, you won't be able to do much. Okay, so now let's learn how to compile. Okay. And we use this new, I'm going to make a comment here. Please don't comment so much in your code as I will in the lectures. Okay, so the \n means that what we want, it means new line. Anytime we want to press enter kind of thing, so press enter, we will use that \n, okay? It will allow us to go to the next line. And don't worry yet about what this means, okay? For now, for this week, just basically use this syntax to write your code. Int main void, curly brackets, and then inside here you'll write something, okay? I will explain it more, but and I'll explain more what int means on Friday, because that's every Friday vibes is variables. Okay, so let's have a look. Let's have a look what we do when we want to compile things. Okay, so we've got this file, and this file is just lovely. It's only got really one line of code, but we want to be able to compile it so that this beautiful human readable code becomes machine readable. Now also I want you to notice when you have gedit open, sometimes this file will have a star next to it. What the star next to it means is that I haven't saved it. Okay, so remember to save your file before you compile it, otherwise your changes are not going to come across. Okay, so let's have a look and we will see what's going on. So in the course, we use a compiler called DCC, and I'll type it into the terminal. The compiler is called DCC. Okay, some of you that have programmed before have used a different compiler. Okay, now that different compiler, please do not use it in our course because it allows you to do certain things that DCC will stop you from doing. And DCC was written here specifically for the reason to teach you how to do C nicely. It protects you from certain things, and it gives you a lot more information when something goes wrong. So when you compile something and it doesn't work, you'll see that that DCC will actually not let you go ahead. And also what DCC will do is it will provide you a lot more information on what the error is and how to fix it. So please use the DCC compiler. All right, so I've said that I want to use DCC, which is the name of the computer program. So the name of the compiler is DCC. I need to tell it also what file I'm compiling. Okay, so the file I'm compiling is called helloworld.c. Okay, and now there's going to be, if I don't specify anything else, the computer will create a file that doesn't, it's called like an a.out file, which you don't need to know that. But what it means is that it doesn't really, it's not very easy to use. So what we also do is we tell our compiler that we want that machine readable file to be called something. And the way we do that is we do a little hyphen and the letter O. Okay, it means that I want to name the file that's going to come out of this compiler, and I want to name it something. And I'm going to call it Hello World as well. So what you've got then is a command that says DCC, the name of the compiler. I've got helloworld.c, which is the name of my file. I've got a hyphen O, which is saying to the compiler, I'm going to name my file that comes out of here something, and I'm going to call it Hello World. So it's got a name as well. Okay, then you press enter and it runs, and as you can see, nothing has happened because there's no mistakes. So that means it's compiled successfully. Now if I list the structure of my directory, it's got 3 files in it. Don't worry about this file here. Okay, what this file is that gedit makes a special backup copy, and you can stop that from happening if you want inside the preferences in here. So don't worry about this, it's just the backup copy that gedit makes. But this is the file that is my output file that the compiler made. So now to run that file, so if I want to execute this file and see what it does, I do a // and then the name of the file that I want to run. So in my case, it's called Hello World, so that's what I'm doing. Okay, and if I run it, it's going to print out, hey, and then it's going to go to a new line. Okay, so a few people have asked what happens if I don't have this new line. So let's get rid of it. I'm going to save it again, and now let's try it again. So I'm going to do the same things again. So if I've changed something inside my code, what I'm going to do is I'm going to compile it again. So again, I'm going to run the DCC compiler, which is the name of the compiler. I'm going to tell it which file to compile. I'm going to use the -o to say what to name the file that comes out. And then I'm going to have a name here. Okay, someone's asked as well, return 0. Don't worry, I will go back to return 0. I'm just ignoring it for now to explain this. But very good question. Okay, so I'll run it again. It compiles successfully. There's no errors. Fantastic. So now to run it, I'll do a dot, I'll do a / and the name of it that I've asked it to call it. And if I run it now, what you can see it does is it types out the hey, but then it doesn't go to a new line. It just puts everything on the same line, which is kind of, it makes things very hard to see. So you don't love doing that. Well, I don't love doing that because it makes everything a bit ugly. So that is the purpose of this new line here, is that it kind of gives it to, it lets it have the new line to move over. Okay, now someone has asked a very good question, so I'll go over it because there's a little bit of time. So we've done we've done the first, applause. We've done the first program. We've printed out hello world to the terminal, except I printed out hey, which is super rude. Let's just change it to hello world. So we have the, and let's run it again. So I've changed it, I've saved it. I'm going to run it by compiling it again the same way. And this is where that up arrow key becomes super useful, because you don't have to keep typing this over and over again. So you can just press the up and then you run it and yay, hello world, and a new line as well afterwards. So you've done your first program now. How exciting. Now, someone has asked something very good. I mean, everything that you ask is very good, but someone has said, okay, I've seen this return zero business. What on earth does that mean? Okay, so what on earth does the return zero mean? And you would have seen it in even my slides as well. Okay, I have this return zero. Okay, so you will find out more about this in week 2 or 3, so don't worry. We will talk more about functions. But basically, our function returns a type, okay? It returns something. It doesn't have to return anything, but we've said that it returns something by specifying something here. So this command here basically just says, I'm going to return 0 is an integer, I'm going to return a 0. But usually the standard practice is that 0 means that this program has run successfully and there were no problems, okay? So everything ran well and there were no problems. Sometimes you will return 1, and that will mean that actually there were problems when things were run. So I'm going to exit out of it and I'm going to return 1. And we will talk more about that. Don't worry. Sometimes I think this return 0 and 1 is the most confusing thing that people see in the first week. So don't worry a little bit about this return 0 for now. Ignore it for now. We will go back to it. We will even go back to it on Friday this week. So save it and we can compile and run it again. So we'll compile it, and every time you make changes to your file, you have to compile it again and then you have to run it again. So again, fantastic to have the up arrow, because it really lets us have this wonderful ability to not type these commands all the time. And so you run the file and it gives you hello world again. How fantastic. So in the last few minutes, I'd like to point out the fact that if you look at my code, I have used some sort of tabs and spaces. I've left white spaces between things. So I'm not just doing random spacing. I'm not just doing random commenting. I'm not just doing random things. When we program, we really want to have nice style, because someone is going to have to read my code and someone is going to have to understand my code. So same way as you're always told, well, back in the day when you were doing exams, written exams, you were told, write neatly, write neatly. This is the same thing. You're writing your code neatly and in a way that makes it easy to understand. So, and that includes having good white space, and it includes indenting your things. So anytime you have a curly bracket, you'll indent again. And we'll talk more about that in our style lecture. So don't worry, this is just your first taste of style. And how to kind of, code it out a little bit. I see someone saying that they love coding. I love that. That's really nice. That's really lovely. So that's fantastic. Okay, so I think we're going to finish there for today. Any questions, please pop them in the chat. And I will look forward to seeing you on Friday. Have a really, really fun tutorial and lab, and getting everything installed and ready to go. Enjoy. And what does indenting do? I'll just quickly answer that. Indenting makes it easier to read. I press tab, and there's a huge, if anyone watched Silicon Valley, there's a huge thing. Do you press tab or do you do 4 space bars? And it's like coding people are separated into those 2 worlds. So anyway, enjoy. So I'll see you all on Friday. Thank you all for tuning in to the first lecture. It was really lovely to have such a lively chat. And I will see you all on Friday.